So our p hat is 0.06. So that's going to land right over here to the left of 0.01, 0.1. Okay. Now, who can tell me what the p-value we're looking for, like how it relates to this diagram? What is really the meaning of the p-value?
P-value, like the area of the curve, that like
some sort of area.
So it's the proportion of times that H naught will be true.
It's not the same as the probability of H not being true. It's not quite the same as that. Maybe Lily, do you have an idea? Okay. Anyone else have? Yep, Tyler?
Is it the probability of getting less than 0.06?
Yeah, the p-value is this area here, right? Sorry, your mic, not Tyler.
Yeah.
Sorry about that. Yeah, so, right, we got a sample proportion of 0.06. You know, this is definitely smaller than, you know, the one that we're testing for, right? So this is some evidence that the actual population proportion is less than 0.1. But the question is, how strong is this evidence, right? You know, if we just got like 0.09 right over here, you know, that's not too far away from this. Maybe, you know, it's pretty believable. That would be just due to random fluctuations. The question is, you know, if you have this thing that's like not too far, not too close, you know, how do we compute how likely it is to get something like this? And the way that statisticians deal with this is saying, well, the probability of getting something, you know, about this small is the probability of getting something this small or smaller. So that is the p-value, right? If there's a really small probability of getting something below 0.06, that's telling us that, you know, 0.06 is indeed pretty far away from this, you know, hypothesized mean, and we can reject null hypothesis. So at the end of the day, this is the p-value. It's the area to the left of 0.06. Any questions about p-value and what it's talking about? Okay. So how do we find that area now? What's the first step of finding some area under the normal distribution?
The z-score.
Yep, you always start by finding the z-score. So we want to find the z-score of that number, 0.06. And how do we do that?
The significance test for proportion, which is p hat minus p naught, etc.
So yeah, so the z-score, it's always p hat minus p naught divided by the standard deviation of this sampling distribution. And, you know, if you look back in your notes, the standard deviation of this thing is p times 1 minus p all over n. And well, actually, these p's are p naughts because that's what the hypothesis, what the null hypothesis is telling us that its proportions are. So this is our z. And now we just fill in all these numbers, right? So we get our p hat was 0.06. Our p0 is 0.1. And then at the bottom we have the square root of 0.1 times 1 minus 0.1 over n. What's our n here again? It's 200. It's always the number of things that we sample. Okay, so this is our z-statistic. It's a z-score of this thing, but in the context of hypothesis testing, it's called the z-statistic instead. Okay? And when I plug this into my calculator, I got negative 1.89. Okay? So now this is just like chapter 3 stuff when we were computing z-scores and using table A to find the area. The only difference is, we have to remember what these different mean is, and what the standard deviation is, and where that stuff is coming from. Okay, so we got that z-statistic. Question?
Yeah, so when you're calculating the z-statistic, it's P-O, and when you're calculating the confidence interval, it's P-hat?
Yeah, so the point is, when we're computing z-statistics, we have p-zeros everywhere, and when we're computing confidence intervals, we have the formula for the p-hat. The reason for that is, in any case, we should be using the population proportion for both of these things to be getting another exact answer. And when we're hypothesis testing, what we use for the population proportion is always dictated by the null hypothesis. So that's why we have p-zeros here. When we're doing confidence intervals, right, we don't actually know what the proportion is for the population. Right, the whole point of confidence intervals is we're trying to estimate what is the population proportion. And so that's why, there's no way to just plug in p, and that's why we use our estimate for p, which is p hat. So yeah, and one of these you use p naught, and one of them you use p hat. But I will be giving you guys the formulas for these things anyways, so you don't have to memorize that. Okay, so any other questions? Okay, let's finish off part B then. So we want to find the area to the left of 0.06. And now we found the z-statistic, and what do we do with this thing? Water? Yep, use the table. So we look up that number, negative 1.89, in our table. And so we end up right over here. Okay? So the area to the left of 0.06 is 0.0294. And remember, this area is the same as the p-value that we were looking for. Okay? So at the end of the day, what is the answer to part B, is it significant or is it not at the 3% level?
Yes, it is.
One vote for yes. How many other votes for yes?
Yes.
There's the yeses. Any no's? Yep. Yeah, so this p-value, so yes, it's significant,